All right. So for example, if I gave you x cubed, right? What would the derivative of that be? It would just be 3x squared. But what if I give you 4x plus 1 cubed? Okay, it's not as straightforward because the inside, I have to also take care of the derivative of that. So I'll just show you what happens. This part hopefully looks expected. And then what we're going to do is we're going to multiply by the derivative of what's inside. Okay, that's the basic rule for the chain rule, is you take care of the derivative just like normal, but then if it's not just an x cubed, I have something else, I have to multiply by that derivative. Okay, so let's take a look. Here's an example. So, right, we know how to do sine of x. What's the derivative of sine? Cosine. And we know how to do the derivative of x squared minus 4. But when we put those together, how do we do the sine of x squared minus 4? So if we kind of, right, what would that look like? It would be cosine of x squared minus 4, right? So kind of like when I did this power rule here, but I have to multiply, I got to take care of the derivative of x squared minus 4, which is 2x. So I would multiply at the end of 2x. So that is the basic chain rule. So here it is in f of g of x notation. Right, so if I have f of g of x, we do the derivative of f of g of x, so kind of like this. Think of sine as our f of x, so we did the derivative of f of x, which is cosine. Kept g of x the same, times the derivative of g of x, which ended up being 2x. And then this is just slightly different notation. This is Leibniz had, so we have Leibniz and we have Newton. They each had their own kind of notation. So like this f prime of x, that was Newton. Leibniz did this whole dy dx stuff. We just have to be used to both types of notation. Yeah,
is this kind of similar to the like u prime v times u prime u?
That's product rule. Or wait, you're saying like plus u prime v plus
v prime u.
So that's the product rule. When I look at when I look above, do we say sine times x squared minus 4?
Sine
of. So it's when f of g of x.
It's like the function of. Or like
Yeah. So remember the little f, the little circle means f of g of x. Okay, so what would be examples of compositions of functions? It would be like, well, I gave you the example on the board here, like 4x plus 1 to the third. If I have any kind of like trig function of something other than just x, it could be tangent of 2x or tangent of x squared. It could also be 1 over 4x minus 5. So it's not just 1 over x, it's 1 over the whole thing. These are examples of compositions. Okay, and then eventually you could have more than one composition. Like you could have
a composition within.
Yes. Which, don't worry, we're only going to do one at first. So let's focus on here. So we'll do kind of the Leibniz notation for just to start, because that uses u. So if this is u, right underneath here, what would du dx be? It's cosine of x squared minus 1. So u is the x squared minus 1. So what would be du dx? 2x. So my dy dx would be Okay, so we're gonna do dy du. So in other words, the derivative of cosine would be negative sign. And then we leave the x squared minus 1 times du dx. So times 2x.
Okay, so the dy over du is just derivative of
If the
u?
outside, yeah, this part. It's just the part, it's just the derivative of cosine. And then we leave whatever is here. We don't change that.
Oh, I'm just talking about the formatting of
Oh, up here?
Yeah, so it's just derivative of u times derivative of y times derivative of u.
Well, it's kind of confusing because it's the derivative of y with respect to u, where u is this, and then times the derivative of du dx. This
So it's like as if u is x,
This
you
is
don't
u.
touch the x.
Yeah, this is u.
So basically you just don't deal with u until the du.
Correct. Yeah, Sophia.
Why can't you do product rule?
Because it's not cosine times x squared minus 1,
Oh,
it's cosine
okay.
of. Now, one thing I just want to rewrite, I like to put the 2x in front because I don't want you to accidentally think that you're multiplying x squared minus 1 times 2x, okay? Sometimes there's nothing we can do to simplify it, but that's what I would do in this case. I would just put that. Yeah, Z.
I'm still kind of confused by the second notation. What's
Okay.
the dy dx? Because it says that
Okay.
y is.
Imagine if, how about if I do the next one? Let me rewrite this. Let me say this is sine of u. Right? Okay. But use, so what would be dy du in this case? What would be dy du? It would just be cosine of u. What would be du dx? This is x to the 1/2, so it will be 1/2 x to the negative 1/2, or 1 over 2 root x. Okay, let's put it all together now to write. I don't always use that full notation because I like to just skip to the end part. So if I say dy dx, okay, so what was dy du? Cosine of u, right? But what's u equal to? Root x. So I'm going to just write cosine root x times, so that takes care of this part. That was dy du. Times, what's du dx? 1 over 2 root x. I'm going to show you a different definition on the next page that might clear that up.
So how do you know when to use chain rule or product rule? Well, because cosine and sine are like methods.
So, okay, sine, cosine, tangent, those are all functions. But, okay, do you see?
I see what you're saying.
Do you see where,
So
like,
chain rule is only for like when you use like strings.
well, or like this one, the 4x plus 1 to the 3rd power. Or if I have 1 over 4x minus 5. Is there anything multiplied to those functions? No. It's something to the 3rd power, and it's not just x.
Okay.
Like I said, on the next page, I'm going to show you, it's called, like, I call it the outside-inside rule. So let's do this next example. I'll explain the outside-inside rule, and then it'll, I think, be a little more clear. Yeah, Zeev.
I might just be not understanding like the notation. When you've got like the dy dx, you're not dividing anything, right? So what does that mean?
It's, when I say derivative, it's the instantaneous rate of change, right?
Yeah.
So the change in y over the change in x. dy dx. That's what that's representing. Okay, so it all goes back to what's our definition of derivative. It's instantaneous rate of change. D, right? D delta, whatever you want to call it, change in y with respect to x. So it's not that you're dividing, it's with respect to time. That's how, like miles per hour. It's just, these were not. So here's an example. Got an object moving along the x-axis. So x of t is cosine of t squared plus 1 over t squared plus 3t. So in this case, it's not just cosine of t. If it were cosine of t, we wouldn't need the chain rule. I've got this whole portion that I have to also take into consideration when doing the derivative. So let's first just remember 1 over t squared is t to the -2.
Oh, that's t.
Right? I don't want to have to do the quotient rule or anything here, right? Okay, so I'm going to do the derivative of cosine, which is negative sine. Keep everything the same here. So that's our dy du. I haven't changed what u is equal to. Times, now I want to do the derivative of the inside. Okay, so derivative of t squared is 2t. T to the -2 will be plus minus 2t to the -3 plus 3. Again,
Negative.
so move the negative 2 to the front.
-2 and
-2 minus 1. Okay, so there's not much I could really do with this. I'm just going to put this part, I'm just going to move it to the front. Again, I don't want to accidentally think that I'm multiplying these two together. So I'm just going to move that in front. So I have negative 2t minus 2 over t cubed plus 3. I think I have some kind of delay here on my screen, so. You guys okay with that, or you want me to plug into the HDMI? It's like every time I look back, I'm like, I finish writing, and then it pops up. Good. Okay. I know, because I had like scrolled, and then it didn't move. All right. So this is what I was talking about. We call it the outside-inside rule. You have the outside, do the derivative. So we do the derivative of the outside, keep the inside the same. That's our u, times the derivative of the inside. That's really all it is. So,
Not too bad.
no, so derivative, so we do derivative of the outside, keep inside the same. And then times derivative of the inside. So if we can at least establish what we consider the outside and what we consider the inside, it's pretty easy. It's just sometimes it's not so clear what is outside and what's inside, and sometimes it's really obvious. So for example, with a trig function, right? If it's like the next one, what's our outside, what's our inside?
Cosine is outside.
3x is the inside.
Also, can we still write y prime instead of 2y?
Oh yeah, absolutely. If we want to, so we can do that.
Because it's just
So that's Newton's.
so much.
That's Newton's. So that's Newton is the prime, and Leibniz is the one who did the whole dy dx stuff. So
I like
it all means the same thing. It's just on the AP test and throughout the year, I'll just use different notation. This is a little bug. It's flying around. Is it a mosquito?
Yeah, it is.
Eh.
I lost it. No, I didn't.
Okay.
No, it's
There,
right
it's
there.
right there.
It's
Oh.
on the board now.
I got
Yeah.
so many.
Where?
It's like
It's
on
right,
top
right
of the
on top.
whiteboard.
If you look at like
top right
the,
corner of the board.
yeah.
You probably can't see it from your perspective.
Oh, like on top, on top?
Yeah.
Yeah.
Can we spray something on it? Like
I
the
mean-
water?
Get the water.
I don't think water's gonna do anything. Here, somebody
Water?
drown it.
Well, no, because it can't fly with wet wings.
Drown it.
Oh, that's so bad.
That's what I literally sprayed Febreze on a mosquito
Oh.
that was on my dog. So I was like,
This is a bad idea.
This is a bad idea. Okay. Oh, somebody kill it.
Where is it?
Where is it?
Can I hit the thing?
I mean, you can hit it, but
Wait, use the water. Oh, shoot.
did we lose it?
No, I found it's like over there somewhere. I lost it now.
Oh shit.
Oh wait, is it on the desk? No.
No, I saw it fly that way. I don't know where it went
Is it on
now.
the wall?
That was
Guys,
Is
I'm
that
gonna
it?
get eaten up.
No.
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 Nice one.
Okay, keep the water
Okay.
in your.
Yeah, we'll just.
All right, you guys keep an eye on it.
If anyone's watching this recording,
CC, as soon as you
I know. Sorry, Madison. There was a mosquito. We're trying to get it. We lost eye contact with it. Okay, we're just gonna be on the alert.
Whatever it's called.
Well,
The scene
Okay.
where she's shooting the ceiling. Is it-
All right. Okay, so just be on the alert. Okay, so derivative of the outside.
So negative sign.
Negative sign. Keep the 3x times the derivative of 3x. And then I'm just going to move that 3. Now, someone in the other class said, can I just do that all in one step? Like, if you notice what's the derivative of the inside, can I just put that in front right away? Sure. Okay.
Yeah,
So-
I feel that would be so sketchy. I would like
Yeah,
forget
I would-
something.
If you're one that doesn't like to skip
Yeah.
steps, then just write it out. Obviously, I
I'll
like
write
to
out
show the work, so when I do these, I'm going to do it in 2 steps anyway. All right, next one. Okay, derivative of sine is cosine. Keep the inside the same times the derivative of the inside.
2x plus
Perfect. Now, obviously, we can imagine this might get a little more difficult at some point. And it will, okay. Some of the problems on the homework we'll have, and we'll also look at them here. You might have a product rule with a chain rule inside, but it's okay. We still just break it down into U times V. Okay, now the next one says,
These are new. That's a square.
yes, that
Squared up everything, right?
is squared. So often with
Is it
trig
just-
functions, I like to rewrite it this way. So now what is the outside function?
X squared.
The squared. And what's
Like
the inside?
Secant X.
So it's not, sometimes it's not as obvious when you see it written this way, which is why I like to rewrite it. So let's do,
Is it just 2 secant X?
okay, so it's going to be 2 secant x to the first times derivative of secant square, or secant is secant tangent.
Yeah.
Wait, so which one is the inside and which one is the outside?
Okay, in this case, 2 is the outside,
Okay.
and the secant this time is inside. So a little opposite of A and B, where the trig function was the outside. Okay, what can we combine here? Just well, these are multiplication.
So it's 2
So-
times
So it's just
secant
secant.
squared x
Yeah.
tan x.
So this will be 2 secant squared x tangent x, and that's all we can do. Okay.
Honestly, I think it was easy.
That's what I told you.
Oh, then that's one.
Okay,
Ooh.
let's rewrite this.
Oh, is this one of those that has like
2 over 1.
Okay, wait. I'm just going to write this as 2 times 3x minus 1 to the negative 1. Now, I could do quotient rule, okay, but I want to show you there is always an alternative to quotient rule. Every single quotient rule could be rewritten as something to the negative 1 power, okay?
But technically you could do it.
You could do quotient rule, but I wanted to show you how you can use chain rule instead of quotient rule. So, all right, now you can kind of ignore the 2 in front. The 2 is just a coefficient. What would happen with the 3x minus 1 to the negative 1?
3.
Okay, so well, what happens with the negative 1?
Oh, negative 1 times 2, and then it turns into a minus 2.
Minus 2 times, what's the
Negative
derivative of
2.
the inside? All right, so here's what I'm going to do. I'm going to leave the 2 just for the moment so we don't get confused. So it's going to be negative 1, 3x minus 1 to the negative 2 times 3. Okay, remember, so that 2 is just a coefficient. We can kind of ignore it until the end. So the -1 comes here, subtract 1, but this isn't just one term, right? We have 2 terms, so we have to multiply by the derivative of that 3x minus 1. Now we're just going to clean it up a little bit. Hold on just a minute. So I have a 2 times -1 times 3, so that will be -6, and then I'll just put the 3x minus 1 squared in the denominator. Because I really don't want to leave negative exponents, because we want to be able to evaluate this quickly. So this is just a different way to do quotient rule. We would get the exact same answer if we did quotient rule.
Wait, so how? Wait.
So I multiplied
Wait.
the 2, the -1, and the 3
Okay.
to get and then this whole thing, I just moved to the denominator because I had a -2.
Okay, so you can,
Okay? Yes, Eve.
So on a test or something, we could just do that by doing the quotient rule, right?
Yeah, if I don't specify, you can do it however you want. But there's sometimes where you can't avoid, like E. There's no way around the chain rule here.
Yeah.
This isn't a multiplication. It's not sine of x times tangent of x. It's sine of tangent x. So what would be my derivative? So derivative of sine is cosine. Keep the inside the same, times secant squared. Now in this case, there's literally nothing I can do with this. I could put the secant squared in front, but I don't need to. This is all you can do. Yeah.
I'm a little confused on like part C, just because, why, how do we get secant x to the power of 1? Like,
Oh, power rule. So the 2 goes to the front,
right.
this, and then we take 1 away.
Right.
Do you remember like when I did it here?
Yeah.
Right, I moved the 3 to the front. I took 1 away.
Yeah, but then like what about like the front, like for D we have that 2 that we're multiplying to the front. Like why don't we?
Yeah,
have
I
that
didn't-
part?
Well, no, there wasn't originally a 2 here.
Right.
That was the power rule. Here, let's try this one because this is going to be another power rule. How can I rewrite 1 over root 2x? Good. 2x to the -1/2.
What? No, why didn't you slap it?
I
Are
don't
you
want to
serious?
slap Harrison.
It'll be fine.
Was it on you?
it wasn't.
Where is
Oh,
it?
where'd it
I
go?
don't know. I think
Oh.
I probably hit it like hard enough.
I
there.
saw it.
See?
It's flying is impaired.
Dude, if you just went like this, Harrison
You
would
would
have
have gotten
recovered.
it.
It's fine.
Harrison
I
would
got one at the
Okay.
pile of how we went.
Do you want to try this one?
Yeah.
On your own? Try it. Give it a try.
It's flying.
No.
It's flying is impaired. Eh?
That actually gave me a heart attack.
Okay.
You just not like, oh, I'm just gonna.
Why did I smack him in math class?
Dude, you have to just go like that and hold your hand there. You just go like this. He's gonna be fine.
All right. Give this one a try.
Is it in your
okay?
Harrison, is it in your seat or something? You
That's
sitting on it?
Can we try it?
Yeah.
I did not split it up like that.
Okay. Again,
No,
you could. This
I put
also
it like
you
root
could.
2x.
you
and then
could-
1.
Wait.
Would
Yeah,
that
but
be
this
fine?
isn't that rule because it's only one thing.
It's just one.
It's
No,
one
no,
time.
because it's the whole thing. 2x to the -1/2.
Alright, I think I got it, guys.
If the 2 was outside of the
I
root,
got
that
it.
would be different.
-1 over.
Let's see.
I don't know how to say that.
Okay, so it's going to be -1/2.
It's like -1 over.
2x to the -3/2
Oh,
times
That's what I-
2.
Oh, wait.
That's what I got it,
Wait,
guys.
why is it
Okay.
times 2?
Well, that's our chain rule.
That's the derivative
Wait,
of
is
the
that-
2x.
That's the derivative of the inside.
Are we just finding the derivative? Oh, it's just of the 2x, not the. Okay.
Okay, now that will allow us our 1/2 and our 2 to cancel, but we still have a negative here. So I would just have a -1
Don't worry about it.
over 2x to the 3/2.
Can you look at my?
could we simplify that to like square root of 2x?
Sure.
Okay. That's
Sure. So, well, if you prefer to write it as the square root of 2x to the third, or put the 2x to the third in the radical. All of those are fine. Those are all fine. Yeah. And
Can I show you mine?
you can show me, and then we're going to look at repeated use of
I
the
don't
channel.
even know what's going on.
I got it, guys. So don't worry about it.
Like if
Here comes verb
Yes.
series.
What?
No, you want to be able to write that all as one
What
word,
repeated use?
because that's not proper.
Yeah.
Okay, so you want to write the whole thing to the negative 1/2.
Sorry, but guys, I'm not getting languages from this mistake.
Okay.
I get a bug bite, I'm coming after you.
Wait, can you go back up for a minute?
Yeah.
Malaria.
No,
Malaria.
Malaria, lunch.
All right.
They carry everything and they aren't even
Sometimes we have more than one composition of functions. In this case, we actually, we have 3. Okay, so we have a tangent, we have a 5 minus a sine, and we have a 2t. All right, so let's see how this works. So first thing what I'm going to do is I'm just going to number, what is our outermost function? Tangent. So I'm just going to put like a little 1 above it so I know that's my first part. The next part I have to take care of is the 5 minus the sine. So 5 minus sine, that's going to be my second step. And then lastly, I just have this little 2t here. That's going to be number 3. Okay, so the way it's going to work is just like the 1 step. So we're going to do the derivative of the outside, keep the inside the same. So that's going to be our first step. So what's the derivative of tangent? Secant squared. So it's going to be secant squared. Keep everything inside the same. Okay, I'm going to check mark. Step 1 is done. Okay, this has 3 parts to it. So when we have 3 compositions, we have 3 steps. When we have a composition of 2 functions, we have 2 steps. So now, basically ignore tangent. We're done with tangent. Just look at step 2. This is now my new outside and my new inside. Okay? So ignore tangent. Tangent we're done with. So what is the derivative of 5? It's 0. Minus, what's the derivative of sine? Cosine. And now we're going to keep 2t the same. So that's my step 2 is complete. Now that step 1 and step 2, we ignore everything else. We're on to the very last thing. What's the derivative of the third part? 2. So that's our...
There is a mosquito, actually, see.
Is it on the ground?
I ate it.
No. So then it's in the air.
Okay, questions on just this whole first step?
Like, don't worry, guys.
Oh wait,
Okay, questions.
You give it a friendly
we're
pat on the back.
multiplying it.
Yeah.
Oh,
It's all multiplying.
I didn't notice that. Okay.
Why is 5 minus sine step 2 and not, like, why are 5 minus sine, like, combined?
Well, because it's technically this just goes away, it's just 0, and then this, you treat it all as part of the same, because it's like if you had a polynomial, you take care of each part, and then if you have something of that, you would take care of that last.
Yeah, but isn't, like, sine of 2t, isn't that connected? Shouldn't they be?
It is, but we also, it's kind of like we treat this all as one part. Let's do some more examples, but let me just, okay, what can I do? I'm going to put the negative sign and the 2 in front, so I'll just make this -2. And there's really not much else I can do to clean this answer up. That's the thing that'll happen here. That's all I can write. And you can put the cosine 2t in front, it really makes no difference.
Excuse me, I have a question. So like for that like 4x plus 1 the cube root, how is that 3? Is like you said like that's the outside.
Yeah.
function. So
It
that
is.
just means that you have to like multiply the 3 in front and then make the exponent.
Yeah.
2.
So we're gonna do the same thing for these next two.
Okay.
Okay, let's,
Wait, it's still secant squared of.
right.
Okay.
Okay, so yeah, Gabe, I'm gonna rewrite this as tangent of 5x to the 1/2. So let's talk about how many steps do we have? What's the first step we're gonna have to take care of? The outermost function is the 1/2. So that's my step 1. What's my next function gonna be? Tangent. And then 5x, that's gonna be my third step. You don't have to number them. I'm literally just doing this for you guys so you can kind of see as we go along. So first step is going to be moving the 1/2 to the front. Everything inside stays the same. To what power? Negative 1/2. Times. All right. Now pretend we're okay with this so far.
Yeah.
Okay, now ignore the 1/2 power. Now I'm just working with step 2. So now I want to do what's the derivative of tangent? Secant squared of 5x. All right, so I have step 1 done, step 2 done. Lastly, step 3, what's the derivative of 5x? Just 5. So I'm just going to make this so just leaving everything with positive up here and moving the 2 and the negative 1/2, putting that in the denominator. Okay. How about try B on your own. Yeah, just a second. Yeah, that's the question. Yeah. Yeah. No. So whenever the power is on the outside, that's so yeah. So anytime you have something to a power, right? This is always going to be your first step. Versus if it's sine of something.
What was sine of that to a power? Then what is the sum?
Like that?
No, like x cubed minus 1 to the power of 2. Then with this.
It's the outermost term is still sine.
Oh, so then you wouldn't use the exponent.
Correct. Okay, did we get an answer? All right, I got -4 times 1 plus cosine 2x times sine of 2x. And if you want, it doesn't matter where you put the sine of 2x.
Right.
Okay, we're gonna do these last two, and we'll leave the last page for not tomorrow, Thursday. But then I'm gonna I'm gonna tell you to hold off on one of the problems on homework because you won't be able to do that. Okay, what do we notice with C? It's
There's an exponent and there's
okay.
Isn't there 5 parts?
coefficient.
There's also multiplication here. It's x cubed times 2x minus 5 to the 4th. So this is a product rule. So okay, so that's okay.
Tricking us.
So this is u, and all of this is v.
Oh, so that's like what you did. Okay.
Okay. Now, if it helps you to write out what u prime is and v prime first, then go ahead and do that. So like what would u prime be? 3x squared. And what would v prime be? Okay, this is the part that uses the chain rule. So it would be 4 times 2x minus 5 to the third times 2. So this would be 8, 2x minus 5 to the third. Okay, so now we know what u prime and v prime. We know what u and v are. So let's put it all together with the product rule. The hardest part of these next two problems is not the calculus. We're going to try to simplify, and we're going to be factoring using some algebra skills. So, all right. I know the hardest, often I tell students, it's not the calculus that's the hardest part, it's the algebra involved. That's where you often make your mistakes. Okay, so. Okay. Did we get that first step?
Yeah, so now we're factoring.
Okay, so we want to be able to evaluate this easily. So we are going to factor, well, I have a 3 and an 8, so I don't have any common factors there. But I have an x squared and an x cubed, so I can pull out an x squared. And I have a 2x minus 5 to the fourth and a 2x minus 5 to the third.
Oh, dude, that's crazy.
So we'll take the 2x minus 5 to the third. All right, and then let's see what we are left over with. Okay, so if I take out x squared, I'll be left with 3 times a 2x minus 5 to the first power. Right, so 3, 2x minus 5 to the first plus 8x, good. So I have x squared,
Wait. Oh, yeah.
2x minus 5 to the third, and then this is just going to be a binomial here, so I'll have 6x minus 15 plus 8x, that'll be 14x minus 15. And we just leave it like that. Right, I just distribute that 3 because that was just to the first power. Okay, got 5 minutes, I don't know. We can do this. So what, do you think they were making a big fuss out of this? Or you think it's still hard? It's a little tricky.
I think it can get hard. Like the chain rule is easy, but like it can get hard.
It can get harder. And these are the types of problems when you have the product rule with the chain rule. Here.
There's a quotient rule.
Okay, so we could do the quotient rule, or we can write this with a negative 1/2 power and do product rule.
There you go.
Do the product rule.
Product rule? Okay, it doesn't really matter. It's all the same to me.
We're doing product.
It's
So-
easier to do product.
Well, no, I
Is
feel
that
like
the-
it'd be easier
is
to
that-
do the other.
du times v plus, yeah. Yeah, that one's easier.
1 plus
Hey, you know what?
2x
It's
to
to
the
me,
negative
it's like not much of a difference,
Can
but
you do both?
I feel like it takes less paper
yeah.
Want to do the quotient rule?
to do this.
Okay, well, let's see.
Product.
Yeah, I know, that's what we're saying, we're doing the product.
Yeah.
All right, so this is our U.
Yeah.
This is our V. If you want to figure out what U prime and V prime are ahead of time, go for it. I'm going to try to do this all at once. So U prime is just going to be 1 times V, right? So that doesn't change. Plus, now we leave U, which is X. Okay, now we have to do the derivative of V. So this is going to be a negative 1/2, 1 plus 2x to the negative 3/2. Don't forget that chain rule, times 2 times the derivative of what's inside. Yeah. That was the calculus part. Now comes the algebra. So let me just rewrite this real quickly. What can I do with the second part? I can just make this a minus x, 1 plus 2x to the negative 3 halves. Right, the 2 and the half will cancel.
Could you just stick x over 1 plus
Wait, why do
2x?
you leave the x after the plus?
Because it's u prime v plus u
Oh,
v prime.
Are we gonna try to take out?
We're gonna factor out. Did you do some of this last in pre-calc? You remember this? So remember, what was the smaller one we were able to pull out? It was the 2x minus 5 to the third. Which one is smaller here? It's the 1 plus 2x to the negative 3 halves power. So that's what I want to take out.
So it's okay.
So what happens when I take this out? I'm going to have 1 plus 2x to the first power minus x. It'll show up hopefully in a second. There we go. Always make sure if I were to distribute this, I should get back the previous one, right? So if I were to multiply these, negative 3 halves and 1, that gives me my negative 1 half power. Distribute here, checks out. Okay. And then I just want to rewrite this. So I'm going to put that 1 plus 2x to the 3 halves power in the bottom. And what do I get in the numerator?
Whoa. Oh my gosh.
Just 1 plus x?
I was looking at the wrong thing.
Why do I keep writing 1 plus 2?
Okay.
It's not terrible.
Not terrible. We only have one page, so this is a